is me. I'm Lena, 27 years old, studied electronic systems design and innovation at NTNU, where I got to learn a bit about coding, not anything about testing, which is sad. Then I started working at Nordic Semiconductor with cloud solutions. And as you might see, I like to spend my free time outdoors, hiking, climbing, traveling. I also run marathons for fun. I don't know, anyone else? Nah? Okay. If you look at the top right, you will see my cat, which I think is the most beautiful cat in the entire world. And down on the bottom, you can see the newest family edition, which is a puppy. I also want to mention that I was inspired by another speech 2 weeks ago, where the speaker added photos of her cats in every slide. So I hope you enjoy watching my dog today. Okay, so the agenda for today is or I can start with the beginning. When I started my job, I started running to a Twitch series called AWS Dev Hour, Building Modern Applications, where I went through a step-by-step kind of guide with videos where you would build an application. And there were a lot of good steps, a lot of good information, but they didn't focus on testing at all. And in my team, testing is really important, and we care about testing all the time. It's important for us. So I was kind of surprised to see that they don't really mention testing here. I think there was a few manual tests, just see that you have something in your database, but not more than that. So I will start by introducing serverless applications and some testing concepts, and then I will bring you to how I worked my way through that series, how I added tests, how you can add tests. And in the end, I will also show how I set up and used the CI/CD. Okay. So first of all, serverless applications. I have not really tried anything else, but I've heard that it's not great to deal with the infrastructure. So I enjoy serverless. It's often event-driven and will kind of respond to events like HTTP request, file upload, things like that. It's scalable, so you don't have to kind of do any manual steps if you want to scale up or down, if you need more storage, less storage. That is also really nice for the cost effectiveness. You only pay for what you need, so yeah, that's nice. The developers can also focus on code, which is great. They don't have to deal with the infrastructure, struggle with that mess, as I've heard it can be. Also mentioned some common use cases here: microservices, APIs, web application, real-time file processing. A lot of possibilities here. Then we're on to why you should test serverless applications. And I'm also wondering how many of you are actually writing tests in your daily work? Yeah? Okay. In our team, we are focusing on tests a lot, and I try to write them before I write code. It's not always happening, but that's how I try to work. And for the serverless applications, you often have very complex solutions, so that's why it can be important to test that they actually work together, you can communicate. You need to verify that events are actually triggering what it should be triggering. Then you could also use it to check the cost models. You can see how the performance time is and how you can kind of make things better. And there's also a lot of rapid deployment when you work on serverless applications, because you can move quite rapidly. And then it's also important to test quite regularly, so you make sure you don't introduce any big bugs that you don't really recognize before it's gone a while. Often using third-party dependencies, which are also, again, important to test to make sure that they can actually communicate with each other. And when it comes to security, you can also test that the security works, that you actually have to log in to access different APIs and stuff like that. And also nice to check the user experience, just go through whatever the user would do and kind of test those different steps to make sure that it has the functionality you want it to have. And for the monitoring, you could also simulate failure to make sure that you are actually seeing when things are failing, because they will fail. Yes, then I will briefly go through different testing methodologies. So first out, we have unit tests. That's probably the test I'm writing most. Try to write it for all the small little functions I have. really, and just run it all the time. So that's just a small automated test. And you use it to find bugs, improve the design, facilitate refactoring. When I usually write tests before I start making the function, I am able to really understand what I want the function to do before actually writing the function, which I think is beneficial. Didn't really like it in the beginning, but I see that it's smart right now. And also when I get back to old code, it's a lot easier to refactor when you actually know what the test is supposed to do and you have a good test. It also makes it better to not introduce any new bugs. And it's important to keep the test small and focused, descriptive names. That's also nice when you get back to it. And also run it frequently. I usually write it before writing the code, as I said, and just run it all the time when I'm making the functions. Some common pitfalls is over-mocking, or kind of mocking something wrong, so you don't really simulate what it's actually supposed to do. So just make sure you are mocking correctly. And also just make sure that you maintain the test, update it to make sure it's relevant. Then we have integration test. I wouldn't say that I use this kind of test that much, because it's often kind of involved in the end-to-end test to see that the system actually works together. But the idea here is to see that the interaction between different components, services are working together, and you want to find problems here as well. So some of the same benefits as previously. I mean, you want to find bugs, you want to make sure that it actually works, that components talks together. And some of the best practices is also kind of the same. Define clear cases. It's nice to automate it. That also counts for unit test. I'm not sure if I had it there. You can also isolate components here, do some mocking to make sure that you kind of test different scenarios. Some of the challenges here is that it's a bit more complex to test. You have to set up some things to be able to do it. You have different components, and you also have to set up environment. Yes. Then we have the end-to-end test. And this is where you validate that the entire application kind of works from start to end. We typically follow user scenarios, saying that the user does something, what is supposed to kind of be at the end. So that's one of the reasons why that's important. Simulate user scenarios and identify integration issues, kind of same as the integration test. But now you kind of see that often more components work together. And also make sure that new changes are not breaking the existing functionality. Best practices here, so focus on user journeys, what the user will actually do. Make sure it's easy to maintain, easy to add things to it if you develop the app further. And also nice to keep it in the CI/CD integration. Challenges here is kind of the same as the integration test, more complexity, setup, need to deal with the environment. But as long as you have done that once, that should be quite easy. And also, could be longer execution time, at least if you have to deploy a lot of code before testing it, it could take a while, but not too long. Okay, then we're on to the actual project that I'm going to talk about. So the basic idea of this project is that you upload an image and you'll get labels of the image back. That's kind of the entire flow of the application. But I can go through what's happening here as well. So first of all, you have a web page with a front end where you can actually upload images and see labels, see the images. And you have to log in. As you can see, authorization up there. And when you're on the website, you can upload images into an S3 bucket, which you see on top. This then creates an event that sends information about the image to a Lambda function, which will run the image through recognition to get labels. Will then store those labels in DynamoDB, and then the web page can get these labels from commands through an API. I will get more into all of this later, but that's like in the beginning. Then I want to quickly go through the different services I'm using in case you haven't heard of them. So Lambda, that's basically just a function, some code you want to be run, triggered by events. DynamoDB is a database, use it for storing labels from the images. S3 bucket is used for storing images and also hosting web page. Recognition is used to getting labels describing the image. So it could be all kinds of labels, objects, scenes, activities, landmarks, colors, image quality. It's quite a powerful tool. And the API gateway is there to help to build the API, can deal with authorization. Cognito is used to add user sign-up and authentication for the app. SQS is used as a queuing service. You can send and receive messages. Okay, then we're on to the first episode. So in this first part, we worked on these, you can see it in the circle there. That's the main part is the recognition lambda, which is kind of in charge of, just here, you have to make a thumbnail out of a photo to show the web page. That's one task. And the second task is to send an image to recognition, where you would kind of get the labels back, and then it should send these labels to DynamoDB. So there are a few different tasks for this lambda. And in this guide I went through, you will kind of get all the code. But I want to do some changes. First of all, the code was in Python. We're using TypeScript, so I want to change that. I also had to change some functions that were kind of Python functions, so I needed to make it sure that it worked on TypeScript. So here I also needed to add some functions that you need to add as a layer in AWS, so it's a bit of a hassle to get some of it in there. I did some unit tests. I will show you some examples now. And I also wanted to start making an end-to-end test for a current system. It's not like a huge system yet, but I tried figuring out what I want to do for that system. So what's basically happening is that you place an image in S3, and the end result is that you want some labels in DynamoDB. So that's what I tested. So as an example here, you can see the lambda. Now, I don't have a thumbnail right now because that it was refactored out as a separate function, but you can see the other things. So you can see that we are getting an event at the top, which will give you the key of the bucket and an e tag. And then we are getting labels, and we are storing labels. So the getting labels is where you send the data to recognition, and you get back the labels, and then you store them. And otherwise, it's just some error handling here. And now I went into one of those functions. So you have the store labels function. That's this one. And there, for storing, you just use a put item command and just send whatever you want into DynamoDB. And when you want to test this, you could always do an integration test and put data in the database and kind of check it. That could also be a bit expensive. I guess we could kind of hope or believe that this put item command actually works, because that's from AWS. So when testing it, I am testing that I'm putting the right things into the command. So I'm mocking the Dynamo send, so I'm not actually sending data to the database. And then I'm checking that I'm calling the mock with the correct argument. So basically table name, labels, and key. So then you kind of know that the code I have written works. And then I'm just kind of hoping that the code that's already there, functions, are working. And here is the end-to-end test. So here I'm also just starting with putting the image in the S3 bucket, which you see on the top there. And then I'm sending a query command to the DynamoDB to see if the labels are there. And then I am comparing it to the expected results. Because every time you send the same image, you will get the same labels. It's kind of easy to check that you have the correct labels. OK, then on to the next part. Here you have a new lambda, which is called the service lambda. This one will act on events from the API, which is either get labels or delete image. So you can use that function to get labels, delete images. Changes here are a bit of the same, going from Python to TypeScript once again. Added some unit tests. I did not change the end-to-end test here because during this episode, you don't really know where the event comes from, if it's an API or what it is, so it's a bit hard to know what to test. Here you can see the lambda. You don't see the entire thing because it's a bit long, but you can see the inside of the function at least. So you're getting an event like previously with an action and a key for the image. And you have the two different actions, get labels, delete image. And you just kind of act on them. You get labels or you delete the image. And I have an example of test here as well. That's also from DynamoDB. So you have a simple function just for deleting the image. And as you might guess, the test is to mock it and test that you're giving the correct commands. So basically the exact same thing as previously. Also the same for get labels. You have a query command giving it some parameters and test it the same way. It's quite easy when you have just started testing one of these to make sure it's correct. And then for the third episode, we dived into API gateway. So we have an API that triggers the service lambda and gets the needed values, like the labels or delete the images. So the changes here was mostly on the end-to-end test, because previously I've just looked into DynamoDB to see if the labels are there. But now I actually have an API that I can use. So that's nice. Did I forget anything now? No. So here's an example from the end-to-end test. You can see the where I put the image in the S3 bucket as previously. Then I am trying to get labels from the API. So just have a function that calls the API and gets the labels. And I also have to retry this function 5 times in case it takes a little while before the labels are good. So I have a retry mechanism that will try 5 times with kind of longer time between each try. Normally it works out in the second try, so 5 should be good. Then we're on to IAM and Cognito. So this is mostly to do the authorization when you log into the app, really, to make sure that you can't really access the API if you're not an authorized user or not logged in. And this made the testing a bit more challenging, because now you can't really just access the API. I need to be a user that's logged in and authorized. So that was something new. So for testing, yes, so the previous test failed now because I'm not able to call the API, just as me. So I needed to make an authorized user and then authenticate that user. You can see the end-to-end test here. I made a function that will give me an access token, which is basically, I think it was a file with around 100 lines with like 4 or 5 different steps that you need to go through. Make user authenticated, start a session, I think you need to change password, just some different steps. But otherwise, the end-to-end test is the same. And then we're on to Amazon S3, which is used for storing images. So we are storing the actual image that you upload, a thumbnail to show at the web page, and also for hosting the front end. When I worked on this, I started working on the front end as well, and I realized that they hadn't really updated any dependencies in 3 years. So I started to update it and see how that worked. Took a while as well. And when I worked on this, I realized that I had some problems with storing 2 different images in 2 different S3 buckets. There were some problems when I updated Amplify, so I decided to put the image and the thumbnail in the same bucket, because why not? And I didn't add any tests here. And these changes was made on a Friday. Just want to say that before we move on. Didn't really think that much. I think my manager was involved as well, but I guess I should have known better. So when I got to work on Monday, I logged into AWS and I saw this. I don't know if you can see what I'm talking about. I was a bit confused when I logged in. I was used to seeing like $1 or $2, and I was kind of thinking, that's $1, isn't it? It has to be $1, but there was a lot of numbers behind that comma. So I did some investigation, and I figured out that when I used the same bucket for both images, I created an endless loop, because putting an image in the bucket would trigger the lambda. So I think I sent like 1 million of the same cat photo through recognition over the weekend. And that's expensive. Yep. Not my proudest moment. Still got the job, so not too bad. So I had some immediate actions after this. We talked a bit about how we could test for mistakes like this, but I'm not really sure because code it's kind of working as it should, just never stops. Guess you could check some monitoring and have some alerts somewhere, but yeah. Also added budget warning after this, so now I get a warning if they think I will spend more than $20. I think it's great to have that limit. I would also get emails every month, every first of the month after this, saying that they think I would spend like hundreds of dollars because they took the estimate from the last couple of months. So I got a small heart attack every beginning of the new month, but now it's good. I also added some caching to make sure that I didn't really send the same image that many times. So now I'm caching the results from the recognition, so the same image would not be sent twice. I would just get the same labels because that's what you would get anyway. Yeah. I also want to mention that we got the money back from AWS, so that was great. And yes, I would love if AWS had like an upper limit of spending. They don't. You can just make a budget, which is a bit annoying. But I guess they earn money on it. Okay, so for the caching, we have the function for getting image labels. And the first thing I do is to try to get labels from an e-tag, which describes the image. So every time I run an image to recognition, I would store the labels on the e-tag. So now I'm trying to see if I have it in the database before doing anything. If I have it, then it is cached, and I will just return the labels from DynamoDB. And if it's not cached, then I would recognize the image, and then store the labels in the cache database, and then return the labels I need. The next episode was on Amazon SQS. That's a queue that will send details about the image to the function. We're using the queue to buffer requests if someone is kind of uploading thousands of images at a time. I also realized that I switched from SQS to SNS, which is also queuing, and I didn't really take any notes on that, so I'm not really sure why I did it, but it's probably a smart move. I think maybe it's because I was sending information to different lambdas, and I think that's easier with SNS. No additional testing or anything here. And then in the last episode, work on the deployment pipeline, because that can be done in AWS, so I tried adding that in this one. So that's just to automate the process, make sure that tests are running when you deploy, and so on. But normally, we are using GitHub. That's not what I was supposed to say here. Okay. So I will go into setting up CI/CD, which is great. So the idea behind this, I have a lot of points here, but the idea is that you want faster release because of many reasons. You want the code to be validated all the time. You want to identify conflicts sooner. You want feedback as soon as possible. Easier to collaborate when the code is out there. Customers can also be happier if you have fast and reliable releases. It's also easy to scale without dropping quality. Then I will just briefly explain how we usually do it. So we are normally using GitHub because you could use GitHub even if you have AWS or some other kind of web service. And we usually have a test and release file. That's kind of the first step. You will install its dependencies, do some formatting, do all the unit tests, you will get the credentials. And we usually deploy all of this to a CI account, which is a separate account, so we can kind of keep that separated from anything else and see how much you spend on CI, for example. We then run the end-to-end tests in the CI account. And then if it's all good, you can release and deploy it to production. And then you come to the next file. We also do some setup versions, get credentials, and deploy it. And this is quite easy to set up. You have to do a couple of things in GitHub, just set some variables and just role stack name. So it's quite simple. Yes, and then I want to mention how this kind of works for me as a developer. So when I'm working on a PR, I have made some changes, uploaded it to GitHub or pushed to GitHub. Then it goes through some setup. Then the code gets deployed to the CI account, which takes approximately 1 minute. Then I run the end-to-end test, which will take about 5 seconds on this application. As long as that's green, I will merge or rebase the code into Saga. And then the same workflow is run in Saga to make sure that it works on the code in Saga, which is our main branch. And if it's good, you deploy it to production. Then it should work. And during development, I'm often deploying the code to my personal account, just for testing different things. So then I will deploy the changes I've made, which could take up to 1 minute, depending on how many changes you have. Running the end-to-end test, again, takes like 5 seconds. Then I just repeat throughout the development process. So this is just how you see when you're working on a PR. You see that test and release is good. Then you know that all the tests are passing. And then you would also release if you're in the correct branch. Also, there's some timestamps here, really. That's just a dependency update, but it's the same with bigger changes. Okay, I think I've been speaking a bit fast. But yes, we're on the last slide. So the key takeaways for me, I think first of all, I would say remember to use budget warnings, because that's could get expensive otherwise, maybe specifically for students, juniors. Also, don't make endless loops. I think most of you know that one, but it can happen quite fast. Also use caching. It's something I hadn't really implemented before this project. I mean, I had heard about it and knew what it was, but I haven't really thought about using it. I think it was great learning to add end-to-end tests to kind of different parts of the project and just add to it every time I make a change. Then I was able to go through it and think from different scenarios and think how I should add the end-to-end test. Also have a lot of experience with mocking different services in unit tests, which is great examples for later, which is the last point. Yeah, I have looked at this application a lot when developing later, and it's been great to have it here. So then I guess we have time for questions, if anyone has any questions, or you can go enjoy a break. Yep.
You mentioned something about that you think we should try to avoid over-mocking.
Yes.
Yeah, I'm wondering a bit what you mean by that. Do you mean that sometimes it's okay to do like small integration tests instead of completely pure unit tests? Or?
I think that was mostly a point I took from somewhere. But the idea for me is that if you are mocking too much, it's easy to mock the wrong thing. So you're kind of, it's not doing what you want, and then you might not get the correct result. So it's a bit harder to get the exact scenario that you want when you mock. So just to make sure that you don't do anything wrong and you know what your application is supposed to do. If that answered the question. I can also show some more code if you're interested in anything. Or not. Thank you for coming.